Is light a wave or particle? In the early 1700s, two great minds are battling for a concept. Sir Isaac Newton believed in light as a particle since you can reflect light, while Christian believed in the light as a type of wave. However, after many years of battle, we still couldn't figure out the answer. This is a really difficult concept. What's up, guys? So today we're going to talk about the most contradicting concept about light. So light as particle and light as a wave. I can show you examples right now. Alright. So this is a mirror that I have, and this is a real door and wall, and I have a laser over here, and what I'm going to do is I'm going to shine the laser on the wall and see what it does. So laser hits right on that spot over there, and then it bounces off to the wall over there, like just like what you do with a basketball. This experiment doesn't show exactly if light is a particle or a wave as shown in the picture. Refraction is also a really good example showing light can be wave or it can be particle. Refraction can be explained by both light as a particle or light as a wave. So let's talk about light as a particle in refraction. Silly lie. Okay, so this is really simple example that shows light as a particle in refraction, and this is what most physicists think of. Okay. Okay, so this is a car. It's traveling this way. Traveling this way. It's the arrow. So it's traveling this way. So what's gonna contact with the muddy water first? Which part of the car? Of course it's this part. Here, I'm gonna color in differently. So this part is this part is gonna contact with the front wheel, the right side of the front wheel. Since this is left, this is right. The right side of the front wheel is going to travel. It's going to get contact with the muddy water first. That means, so what happened if it's only one wheel contacts with the muddy water? It will change direction. So it will end up like, let me delete this. So you will end up like, so you end up like going to here, so it would change its direction. So instead of going this way right now, since the wheel would change its direction and it will go to this way. So refraction, it acts like a particle. So that's why we can think refraction is when the light travels as a particle. So light as a wave in refraction. So first, the wave is traveling over here in this direction, and it got in contact with the water, so it's So a lot of waves are suddenly change direction since it's slowing down first over here. So it slows down, and then the previous wave just kept on gliding, and then so it turns out to change its direction over here. So look, this is a little bit way early. It wasn't even contacting with the water. So but it changes its direction anyway. So the wave would keep on traveling, and when it got out, the light has its freedom, and then it travels. So it travels back to its original direction over here. So this is basically how light as a wave, and how it works in refraction. For our first two examples, we show how light can be a wave and a particle. But this example may change what you thought light. So I have here, it's a laser that I taped up, so it only has 2 slits on. So we would expect it to have, when I turn it on, we would expect two light strand on the wall, and let's test it if this is it true or not. Alright, yeah, I'm gonna put this on over here, and it's gonna do it. Alright, I turn it on. Alright, so let's go to check it out closely. Alright, so here we have Young's famous experiment, the double slit experiment. So as you can see, there's a big slit over here. It's because of the laser itself, because I didn't tape up well. But you can see it's actually for every single layer, there's like different layers. It actually spreads out from middle, so the intensity spreads out from middle to the outside. So this is the single slit and double slit experiment result, and this is what it should look like. We haven't talked about single slit yet, but I will. And double slit experiment, we just did the double slit experiment, so here I'll explain why right now, and we'll leave the single slit experiment later. So here I have a picture of Young's double slit experiment and how it works. And you can see the reason why it's a wave. So here's the sunlight came down from here to here, and it only goes through one hole. This is the tiny hole, and then it spreads out like a wave, and then it actually hits the 2 spots over here, which they are the only slits in this experiment, and it spreads out, and then it goes like, and then since the light has up and down part, and it means, so it intersects, so some up and down part will intersect and will cancel out each other, so that's why it has a dark spots, and some spots that have common, they are either both up or down. They produce a really intense light pattern, so that's why it creates a pattern like this, but instead of just 2 slits. We have a laser over here, and it's taped, so only one slit is open. So let's just open the slit up to see if anything strange happened. So if you have normal logic, when you have only one slit open, when the only one slit open, the part thing, oh, you only has one slit, and then it's gonna be like really thin. It's gonna be like this, but since this is this. I'm gonna turn this on. Some blue. Oh, okay. So we have a laser over here. So it's the prediction's bright, so there is this type of strand of light over here. It's going down, but this, I have no idea why this is happening. I think it's something to do with the laser, but here, I'll go check it out. I'm gonna take it up a little bit, so. Alright. I'll turn this off. So we're gonna make this less thinner, way thinner than before. So let's do this. Alright. So we should see a thinner thinner line on the wall. Really? Alright, so this is really weird. Okay, I'll turn this up a little bit. Yeah. Alright, let's go check it out. But it seems like the size of the line didn't change at all. So it's obviously getting wider. As you can see, let's go do a close up look. So it's actually getting wider. Here's how wide it is between my fingers. This is how wide it is, like from like the intense part to the outer part where at least I can see it. Where like the light's thinning out. So that's weird. It acts like a particle before, but right now it acts like a wave. So this is an explanation for what we just saw for the single slit experiment. We have a laser on the left, and it comes out, and then it acts like a wave, and it hits only one spot, and it spreads out, and then hits a wall. So it produces so the thing spreads out. The photon spreads out. Alright, but Heisenberg has made a really weird equation that describes this experiment as a type of particle. So here's famous Heisenberg's uncertainty principle. Delta x times delta p is greater than or equal to Planck's constant over 2. Alright, what does this mean? It means that delta x means, so this is light as a particle. This is a particle. So delta x means the possible area that the electron can go. I mean, not the electron, but the particle can go. It can go up, down. That's the maximum it can go. So this is the area, and delta p is momentum. So delta p is the way they can go, like the direction they would go. You can go all the way to here. This is the maximum, and this is minimum. And these are not drawing scale, so yeah. And I'm just making a really weird example, and it can go like all the way down. You can only go. You can only go these, like the area over here. Planck h bar, which is Planck's constant, it's a constant. It's a number. Let me search it up really quick. Okay, here. Alright, let's go. Planck's constant. Everybody loves Google, so I'm gonna use Google. So that's a number. I think you guys both. My bad. So that's a number. That's a number over here. That's Planck's constant. All right. So let's go back to here. So Planck's constant. So delta x times delta p has to equal to Planck's constant divided by 2. I mean, it has to be greater than or equal to. So what we did in the experiment, we decreased the delta x. So we had to increase the delta p. That means the particle will have more space to go. So that's why you would produce a really wide pattern. Like this is, let's just say this is middle, and this is all stuff. Yeah, that's why you go produce like something like this instead of producing something like this, just a line. All right. Light as a particle. I didn't do the experiment, but I'll try to explain why light is a particle. Photoelectric effect. This is a famous phenomenon made by scientists. They figured out that you can actually bounce light on a piece of metal and electrons will flow out. As you can see on the picture, they only use blue out of all the rainbow color to bounce the electron off. So this is the conclusion, guys. So this is it. This is the answer. Even though after many years of thinking light it's a wave, those scientists, with like all those evidence, Albert Einstein actually think light actually has some particle characteristics, and William Watson, so I just try to remember the name. He believed in light. It's not a continuous wave, but it's like a little chunk, and there's like missing wavelengths between all of them. So Albert Einstein, so he believed in light can be a wave or a particle. The name, which is duality. So sometimes it acts like wave, sometimes it acts like a particle, and that's why he actually called light as a photon. It starts out with quantum, but then he changed the name to photon. Yeah, and then I think the answer to this question is both. Yeah, it's both. Alright. Albert Einstein, he thinks that the electron can absorb some property of light, which he first used the term quantum, and then he changed it into photon, and this is how he starts. And the answer to this question is, I think the answer to this question is both. Well, you guys can argue. All the scientists have argued all those years. We still we think what if something pops up and then we're gonna change the entire whole answer again. But yep, thanks for watching this really boring video. No, just kidding. I don't think I had a lot of fun to make this video, but I had a lot of reading to do. I have to think a website, which is I'm gonna show right now. So this is a website I did most of my research on, and also I use Google. So if you guys have any questions, just feel free to ask me, or just go to Google, or just visit this website. Thank you, and yeah, we're done.